So today we will continue transient analysis, but on the topic of waveform synthesis. It's called waveform synthesis because each wave is synthesized into parts. Any unknown wave is obtained in terms of known waves. That's why it is called synthesis. So you can observe how I am dealing. Each waveform I am going to convert into in terms of standard waveforms. Therefore, first we will see standard waves. What are the standard waves that we have and how to convert them? So we will see the standard waves or functions, then their Laplace transforms also. Then we will enter into transients with different waveforms. The first one is impulse signal. Impulse is delta t. That means it is a value, it has a value only at t equal to 0 and all other places it is 0. Unit step in time domain, it's called u of t. U of t is equal to 1. Please observe here. U of t is 1 in the time axis. Then unit ramp signal in time domain, it's r of t we call, r for ramp, u for unit step, then that value is t. When you say r of t is t, what happens is you can observe this is 45 degrees, just like slope is 1. So this is a third signal, standard signal. Fourth signal is unit parabola signal in time domain. Let's say p of t, t square by 2. This is the shape, parabola shape. Now I am going to make some mathematical operations. Suppose if I differentiate parabola, what will happen to t square by 2? Half. Differentiation of t square is 2t. 2 and 2 cancel, it comes as t. That's called unit ramp. So differentiation of parabola is ramp. Then differentiation of r of t by dt, that means what is r of t? We call t. So differentiation of t dt by t is 1. We call it as unit step. So this is how mathematical equation. Still you see differentiation of parabola is ramp. Differentiation of ramp is a step. Differentiation of step is an impulse. This is a ramp. If I differentiate t, it becomes 1. If differentiate here, it becomes impulse. So these three, if you remember, most of our problems are solved. As I said, let us understand standard inputs, then convert them into any waveform that is required. Laplace transforms. Laplace transform of unit step is 1 by s. Please remember, step means a value, but unit step means value is 1. Laplace transform of unit ramp, 1 by s square. Laplace transform of impulse is 1. Laplace transform of unit parabola is 1 by s cube. All these transforms I already discussed in the previous lectures. You please refer that part in order to really understand this, because I am only giving some immediate ready reference. But all the Laplace transforms I already discussed earlier. So make use of them. Laplace transform of u of t minus t e power minus st, because shift in time domain exponential multiplication. This is ramp, means e power minus st by s square. Like this, these are the standard functions and their respective Laplace. Then I will illustrate the concept with some problems. Let's go to problem 1. Calculate V of s for step signal. This is a step. For this we need to calculate Laplace transform of step. This is V naught into ut. Applying Laplace transform V naught by S. Let's go to second problem. Calculate I of S for the circuit shown in figure. We have to calculate current in this circuit. Please observe, because the inputs are complicated, I am going to take initial conditions very fast, because in the last class we have spent one full lecture on initial conditions. Okay. Now if this is the circuit, for t0 minus I is 0. Why? Inductor could not develop any current. Then if I is 0 for t0 minus, I is also 0 for t0 plus. Why? Inductor cannot change its current instantaneously. So what was the current is there now. Now let us take t greater than 0, we apply KVL. What's the KVL here? V of t Ri L di by dt. Then we have to take Laplace transform. V of t will become V of s R plus Ls into Is. Actually I of 0 also should be mentioned here, but that is 0. So I of s is equal to V of s by this R plus Ls. For every RL circuit, network impedance is same. You can simply say R plus Ls. Hence I of s is varying with respect to Vs only. So please look at here, I of s is equal to V of s by R plus Ls. Okay, that's the meaning. Now as V of s changes, I of s will be achieved. So I am going to take 10 different approaches, or at least around 10 problems, to illustrate how to calculate this V of s. So what's going to change from problem to problem? Only V of s is going to change. And then you have to calculate respect to I of s. Then take inverse transform. As I have been telling, in objective exam they cannot ask you to calculate I of t. They will simply say I of s. If you can calculate I of s, that is more than sufficient, an equation, that's all. So we are going to observe different inputs. Circuit is same, what we have to calculate is same, but only input is changing. That input is changing in terms of u of t. So therefore in the waveform synthesis, I have given the idea of applying that waveform to transient analysis. The very purpose I have taken this inductor is initial current is 0. When initial current is 0, let the input be anything, current is always, initial current is 0. Therefore one word to say, I of s is equal to V of s by Z of s. So that is the illustration in this problem. Let's go to third problem. Calculate Vs for the figure shown. Now my analysis is started, synthesis is started. It is just like take a scissor, cut up the pieces and join them. Suppose if you have to get this wave, how do you achieve? Look at here. This is u of t. Subtract this one. When you subtract the upper one and lower one, this portion is cancelled. If this portion is cancelled, what is remain? Only this pulse. So this is called a pulse wave, but that pulse is written in terms of ut u of t minus. That's why I have written V of t is equal to V naught into u of t minus V naught u of t minus t. That means I am subtracting these two. When I subtract these two, the pulse is available. Therefore, now take the Laplace. V of t will become V of s, V naught by s, V naught by s into e power minus ts. That's why V naught into 1 minus e power minus st by s. So this is Laplace. Please understand, I am only calculating Laplace. Once again, if you want to take inverse, you can calculate. So idea is calculate Laplace transform of the input. See, what do I do with this V of s? I'll take this V of s and substitute in the expression of I of s in the previous problem. then you will calculate I of s. So calculating I of s for different V of s is our illustration today. So main focus on the input but not on the circuit, because circuit is same. Wantedly I am not changing the circuit. Suppose if I change the circuit and input, you will not able to understand. That's why let me fix the circuit and only change voltages. That's our third problem. Before I go to some periodic signals, I want to tell you how to calculate a periodic signal Laplace. The signal will be repeated for every complete cycle. That means f of t plus nt is equal to f of t. For periodic signal, the Laplace transform of f of t f of s by 1 minus e power minus st. How? That I will illustrate in the other problem, how each one is taken. So this is a standard one. For example, you want Laplace transform of any periodic function, take f of s by 1 minus e power minus st. For every function, 1 minus e power minus st has to be added. By including this term or this factor, every time you will get periodic function. So whenever there is a periodic function, calculate for ordinary, simple, non-periodic signal that you repeat. For that reason, f of s by 1 minus e power st is used. So that is the meaning here. Now calculate V of s for infinite staircase periodic function. Calculate V of s for infinite staircase periodic function. What it is? Look at this function. Okay. This is called step. This is another step. This is another step. That's why I call it as staircase. Infinite staircase because this is continuing. But this is continuing for every t. If it is continuing for every t, what do you mean? U of t is added at every time. Indirectly, we call it as unit step became periodic. Repetition of unit step is called staircase. Staircase there. Now look at here. As I said, I will illustrate. I am illustrating now. U of t is V of t is equal to U of t plus U of t minus t, U of t minus 2t, U of t minus 3t. Then what will happen to Laplace? V of s 1 by s, e power minus st by s, e power minus 2 because this 2 becomes here, e power minus 2, e power minus 3 whole divided by, for each one there is s. If you take common unit step as 1 by s, 1 plus e power minus st, 1 plus e power minus 2 st, e power minus 3 st, so on. So V of s is 1 minus e power minus st whole power minus 1 by 1. So please observe, for every periodic function, as I told you, take 1 minus e power minus st whole power minus 1. You call 1 minus e power minus st whole power minus 1 or 1 by 1 minus e power minus st, they are all same. So that is about Laplace transform of infinite staircase, right? Fifth one, calculate V of s for finite staircase periodic. It's a finite, that's all. It's only periodic for 3, so it's not really periodic, but it's also called non-periodic, but only periodic for 3. So what should I do? Look at here. Just like previous, I will say u of t, u of t, u of t. So u of t minus t, u of t minus 2t minus 3 into u of 3 minus tt. You know why? This value is 3. So if I cut 3, that becomes 0. So if you take Laplace, u of t is 1 by s, e power minus st by s, e power minus 2t st by s minus 3 e power 3 st by s. Now take common 1 by s, 1 plus e power minus st, e power minus 2t minus 3 into e power minus 3 st. Laplace transform. Let's go to sixth problem. calculate V of s for square wave function. What exactly it means by square wave? This is V1, V2. Repeating for t. If it is repeating for t, half time is called t by 2. So then how to synthesize this? You can synthesize this as first part as u of t minus t. That's the first part. After finishing first part, what should I do? As I said, first 1 by s you take. U of t minus t by 2 is e power minus st by 2 by s. This is for the first part. Then how to get the overall part? Whatever you got first by 1 minus e power minus st. So look at here how I did. I am dividing the whole function into v1, v2, v3. v1 is there as it is. v1 is, second one is shifting of the first one. Third one is shifting of the first one 2 times. So if you take Laplace transform, this comes here, and e power. If you take inverse, and if you take common 1 minus e power minus st, that's like binomial expansion. Therefore, if you substitute it is v1 by v1 of s 1 minus e power st by 2 by s is v1. That was last answer. That answer you put along with e power 1 minus e power st. So what is that? Can you really observe one thing? How did we achieve this one? Most of the objective question examination, he is not giving this answer. He is giving this answer. That's why I always say in GATE exam, do it. If the answer is not there, adjust the answer. If you still don't find it, readjust the answer. So do it, adjust it, readjust it. Even after that you don't find it, leave it. Don't meddle with it. But let me explain how come suddenly this came. How did this disappear? Very simple. This 1 minus e power st, you can write it as a plus b into a minus b. That means 1 plus e power minus s by 2 into t, 1 minus e power minus s by t. This one cancel and the remaining will be here. So this is the final answer. So here I am trying to say how to understand how to achieve Laplace transform of periodic functions. Square wave is a period. Remember one thing. I said 3 words. Understand the step. Okay. And if you want a pulse, pulse is nothing but 2 steps. So 2 steps will give a pulse. Then if the pulse is repeated, you will get a square. So from unit step to pulse, from pulse to square wave, all the 3 are one and the same. That's all we have done in between. So all these problems into one word, all are functions related to step. Now let me take you to the ramp styles. I have divided my lecture into basically 2 things: step and related functions, ramp and related functions. Now calculate V of s for infinite ramp function. This is a ramp. This is infinite because I said going on. So as you see, you can say V naught r of t 0 to infinity. If you apply Laplace transform, ramp is 1 by s square. So V naught by s square is your answer. V naught by s square. 8th problem. Calculate V of s for finite ramp. If the previous was infinite, now it is finite. So look at this finite. Why it is called finite? This is ramp for some time. This is a ramp for some time. After that, finite. Ramp for some time. That's why it is called finite ramp. For finite time, it is ramp. So what do you guess? How do you guess to achieve this? The answer is here. If I want to achieve this portion, I need to cut this. If I have to cut this, equal slope I have to take. So this is V naught r of t minus V naught r of t minus. Then if you apply the Laplace, okay, r of t means what? 1 by s square. Then r of t minus t means 1 by s square e power minus st. So if you take common v naught by s square 1 into e power minus st. That means this positive slope and negative slope, those two are cancel, you will get 0 slope. By mistake some students are thinking these two will be over, it will become a sawtooth wave. No, it will become finite. So if you want to have a sawtooth wave, that is a different problem. But here, if two slopes are cancelled, they don't become 0 value but 0 slope. 0 slope means constant. So that's what I mean by ramp. Now I am asking for sawtooth wave. Calculate V of s for sawtooth wave. What happened? V naught t. If you say V naught into t, what will happen? As I told you just repeat the previous problem. Only that extra portion is there, remove it off. And see, observe what I am doing. Just like previous, this positive slope, negative slope is cancelled. Then you got a constant. And this constant you have to remove, use unit step. That means V naught r of t, V naught r of t minus t minus V naught u of t minus t. So these portions are cancelled. You got a step here. Got a step. So this is called sawtooth wave. So sawtooth wave means that extra portion u of t has to be removed. Now please Laplace transform V naught by s square. V naught by s square into e power minus ts. V by s square plus, this is not s square because step only s. So this is your Laplace transform of that signal. Okay. So then calculate V of s for the periodic sawtooth function. The same as previous sawtooth. Whatever that we studied there, we will be repeating. That what is the answer? As I told you, whatever the function you have divided by 1 minus e power st. 1 minus e power st is your function. Let us see. Just like previous function, whatever that we have done earlier, then call it as v1 divided by the total will give you the overall. So overall will come only when you take first part divided by repetition. So whenever there is a periodic signal, please understand 1 minus e power minus st has to be considered. Then 11th one, calculate V of s for ramp and step combined. This is ramp and step, both are combined. When the ramp and step is combined, how do you say? Look at here, I am going to do. First I will take slope. You must be very careful about slope. Observe me. The slope is 4. Actually speaking, 4 minus 0, 1 minus 0. If the slope is 4 r of t minus 4 r of t, what will happen? Both slopes will cancel and become 0 slope. And then minus 2 into. Why should I take minus 2? When the value is 4, I need to cut only 2 portions. So from 4, it will back to 2. Then how to cut from 2? That you have to cut from here. So observe my equation. I am writing clearly, slowly. 4 r of t minus 4 r of t minus 1 minus 2 another 2. The only difference is here it is 1, here it is 2. That's the meaning you have. Then you can take Laplace transform. Calculate V of s for the figure shown. Figure shown. See, this is a triangle. For this triangle, what do we do? How to calculate? The answer is very simple. Look at here. This is 2VRT by t, 2VRT, then minus by this. If you cut these two, you will get this portion. But plus 2 minus 4, what comes? Please observe here. Plus 2 minus 4. What's coming? Minus 2 is coming. Because this is minus 2, you see what I am taking. I am taking plus 2v naught. So minus and plus will cancel. That's why you will get this waveform. So you will get a triangular waveform with this way. That's the meaning of how to achieve. For that I am writing 2V0 minus 4V0, okay, plus 2V0. So if you see that, you will understand what comes, how to get the actual transform. Now what is 13th one? 13th one is nothing but repetition of previous. Whatever you got in the previous problem, please put that divided by 1 minus e power ts. So as you observe, all that I am writing by 1 minus e power st, v1 of s by 1 minus e power st. Every time whatever you get divided by 1 minus e power st. Okay. Now 14. Calculate v of s for the periodic impulse. A very peculiar problem. This is impulse, this is impulse. Impulse is repeated. So how do you get the answer? Again the same answer. Whatever the Laplace of the first one divided by 1 minus e power ts. Look at there. Laplace transform of impulse is 1. Please remember, Laplace transform of impulse is 1. Any transform of impulse is 1. So 1 I am writing here divided by 1 minus e power minus st here. Thereby you can easily understand how this coming up, 1 minus e power minus st. This is the answer for this. Then 15. Calculate v of s for the cosine wave. Please observe, cosine generally at t is equal to 0, cosine is maximum. So this is a cosine wave, time period. So v of t is a cos omega t. If you apply the Laplace, as by s square plus omega s square. That's the different illustrations of using different waveforms. So finally I am concluding the point. Synthesize the given waveform in terms of known waveforms. Did you observe what I did? I have done only two things. I have used in terms of step and I have used ramp. Using step I have developed 50% of the problems. Using ramp I have developed the others. So by using the step and ramp and impulse, which are very famous problems, you can always synthesize any wave in terms of these three things to achieve the overall Laplace. Finally, don't forget, the very purpose of calculating v of s is to calculate I of s. I of s is equal to v of s, whatever you got, divided by z of s. So let them give any circuit, z of s is there, and v of s by z of s will give you the current. So the whole exercise is to calculate v of s because z of s is r plus ls. As I told you, circuit is fixed. I am fixing the circuit, I am varying the inputs to calculate the I of t. But understand, because for objective exam, calculating the inverse Laplace is very complicated. Most of the time we will stop, or they will also ask the same. Obtain the Laplace transform of the so and so. So that is the purpose and the approach and the conclusions of this topic called waveform synthesis, that is useful in transients.